Glad to be here, glad to be opening the track, and I'm gonna, this year I love to talk about service objects. I spent a lot of time thinking about them and thinking about how to think about them, so I'm gonna be sharing some of my learnings. A little bit about myself. I'm on Rails since 2006, so it might tell you something about my age. My current role is CTO at Settle.com, where we help companies manage their assets and licenses and do it in an easy way. My passion is complexity, organization optimization, so that not that I only love to organize complexity, I love to do it in an optimal way. My consultancy called RBBR Limited, we help small to medium startups to grow their code base so that they don't lose scalability over time. And my methodology is painless Rails. It's not too popular yet. I hope one day it's gonna get a bit more popular. A few links below. Feel free to visit them to follow me and read more about my stuff. And what I'm gonna say is service object is a fake concept. This is my statement, but service objects nowadays, they are a de facto standard of a standard way to organize complexity in Rails applications. And still, I do think so. And this year I gave 1 hour talk about the curse of service objects in Poland, in Wrocław, and today I decided to reshape my talk because first of all it's 30 minutes. A second thing, I decided to focus on one thing, the shape of a service object. But to talk about the shape of service object, I first need to tell you about one thing I invented several years ago. It was mostly a joke, a funny thing to do. But I call it code topology notation, and these days I find it more and more useful, and as well as in discussions about architecture, about software decisions, and also on a day-to-day job as well, to kind of model things and try out. So, the notation. The basic idea there is to display objects as little dummies. And their hands are represent methods. So kind of in order to invoke a method, you shake a guy's hand. And if you take a closer look, you might realize that fingers actually represent arguments. So the more arguments, the more fingers. But they are kind of not a normal fingers, but robo fingers, like robo tube fingers, so they can accept arguments from outside and maybe store them for later usage in some other methods. So I hope you're still with me. And to return the method, there's a hatch on the belly which opens, and you can grab a result there. And also private methods, my favorite concept. Those are kind of internal hands which only the guy himself can shake, but no one from outside can. And there's more to it, but like the one more concept we need is a class. And the class is a kind of spawning platform with instructions what object to spawn, and there's a lever, and you pull this lever, and you get an object. And of course, you can get as many objects as you need. And what is interesting is that essentially both objects and classes, they have the same topology, because lever could actually have arguments, could actually have fingers, and it's the same thing as a hand. And the same with a hand. It can have no fingers, no arguments. So, and one example of application of this topology is that you can, first of all, you can reflect complexity of your code by simply expressing, by simply drawing those little dummies and their arms and how it looks like. And here you can see how complexity grew over time when code was getting more and more complex. So this is exactly how are we going to talk about the shape of service objects. I did small research recently, and I was looking for how developers think, what they think service objects are, what they're useful for, and how they look. And I'm gonna quickly show a few examples of service objects I found on internet. And on the right, you can see their shape in our code topology notation. So this guy is simply a wrapper around Twitter API. And you see, like, we have a constructor with one argument, and we have one public method. Here we have a book creator, service object called book creator. Again, we have a constructor with 4 arguments. Public method can accept any number of arguments, so we have this kind of funnel instead of fingers. And we also have one private method, which you can see there. Again, like few more examples, and you can see they kind of, like, the code might look a bit strange for some of you. Like this example, for example, it does some validation. For some reason, it's still a service. This one, it just does simple calculation in one line, and it's still a separate class and a separate object. But anyway, and there are also, like this example is a little bit more complex. There are 4 private methods. But if we try at this stage, looking at just these samples of code, if we try to derive an idea of service object out of it, the definition would be pretty much it. They just do stuff. And they all look the same. They share the shape. So the shape would be, okay, there's a constructor. It usually accepts some arguments. There's a public method with no arguments. And there could be a number of private methods. And serious guys are doing it too. I'm going to show you this example of a service object from GitLab, from the code base of GitLab. And it is, the code is around 200 lines of code. And I'm going to show you how it looks in this notation. It looks like this. So, but what's interesting is that at the beginning it actually looked not too scary. So I look at the history of those changes, and in the beginning it looked exactly like we've seen at the start of my talk. So, and yeah, it looks like over time, if you do practice service objects, if a certain area of your project will become more complex, the complexity will grow inward. And for me, it doesn't look like an optimal way to organize complexity. And let me show you how I would do it. So my methodology, I think there are 3 pillars, 3 main principles. Like, first of all, please do practice layered architecture. Please make sure your abstractions are of a single level of abstraction so that they don't kind of jump around multiple layers and around multiple levels of abstractions. And the third one, this is the one which we're going to be focusing on. And if you haven't been listening to me at all, and you will remember only one thing after my talk, I want you to remember this thing. So think about this idea: splitting code into different building blocks by the types of work this code is doing. And let me show you what I mean. We will take this service object, which is not too big like GitLab's, which is already not too small, and there are, like, we can already start considering refactoring of it, or at least we can easily demonstrate the idea of types of work here. So I'm not sure if you can see it, but below, like what this code does, it sends an email, so it uses some external service, and you can see here I kind of highlight arms of this guy to represent where this type of work is located. So here we can see mutations. So we do mutate, do some changes in the database, and this logic is spread across two private methods. This one is what I call business rule. It is where we ask a user about something, not about something, about himself. I mean, user entity. And again, this logic is spread across two private methods. And we can also see that service object also works to some extent as a controller. At least it has a notion of session, it has a notion of JWT token, it has a notion of rendering. At least it prepares success or result and response. So yeah, we can see that here the guys take care about all those types of works. And let's see what's going to happen when we try to rearrange it so that each type of work is done within its own building block. Let's find its own shelf for every type of work being done here. So first of all, let's extract business rules. And luckily, in Rails, we kind of already have a proper shelf for business rules. If we ask user about himself, let's maybe just move it to a user model. And yeah, that's the code. That's the shape of our user. We just added two methods to a user model. Okay, next step, mutations. And this might be a not very obvious move. What I do here, I introduce a concept of mutators, and those mutators are just functions, and I just move all the logic, all the creation logic, all the update logic in one single procedure. So it's not, the logic is not getting split across multiple models in callbacks, for example. It is all in one method. It's explicitly, it is an explicit procedure. So, and module I use just as a container for those functions. I call it user module, I call it user mutator, but the actual mutators are functions. So, yeah, we introduce basically two functions here. Next move, let's extract all the controller logic back to the controller. So that, because before that, our service object was working as a controller, and I assumed that controller was just calling this service object, and it was mostly empty. So it was maybe too skinny. Okay, so we just moved some logic to controller, and we, like, obviously we already had this thing. We just modified the create action. Okay, and once we moved everything out, let's see what's left in our service. And again, it's just a function, or more correct, procedure. Again, it is located within a module, but it could be a class as well, because the topology is the same. I'm not creating any objects here. It's just a method which accepts 3 arguments and does its job. And you can see that it calls user, it calls some methods from user model. It asks to do some job for user mutators, and it calls, it invokes a method in a user mailer. So instead of us having like a big piece of code doing lots of different types of low-level work, we now have a high-level code which we fit in a single function. So this is what we did essentially. This is what we had, and this is what we've got. So we introduced 5 methods. We modified a controller action. 2 methods went to a model, and we introduced 3 methods, and we found kind of building blocks for them, which are simply containers of functions. So here you can see how we distributed all the types of work across different building blocks. And interestingly, if we try to draw how it's used, it looks like our user is getting used by user mutator. Our service uses mutator, and it can use model as well. And controller can use any of them, basically. So, and it will be very strange in this architecture if you would try to use a service from a mutator. It's not what you expect here. And basically, you can easily spot that if you prefer isolated testing, this setup would be much easier to test. Also, this is what we call modularity. And this is what we call layered architecture. And I want to remind you that Rails is supposed to be a layered architecture. It's just that there were just 2 layers, models and controllers. And with the idea of service objects, what we wanted to do is to actually introduce another layer, kind of service layer. But I think as a community we failed, and essentially we have no layers anymore. But this is what we've got with mutators and with services. This is an architecture what we've got. Like in the core we have our primitives, our entities, models. Then we have mutators who can operate with our entities. And then there are more high-level abstractions like services, which represent business operations in my code. And they are kind of smarter things. They can operate with mutators and models. And controllers, like they manipulate all the things below. So, but one could say, wait, we could still, while refactoring that service object, we could still put those we could still use service objects for those types of work, right? And let's do this. So this is the code which I put like 2 methods to a user model I extracted. Let's put them in a separate service object instead of doing this. So I create a class called user business rules, and there's a constructor, and there are 2 public methods which actually give us answer about this user. User mutator, we turn it into 2 service objects with the names login event recorder and failed login handler. And yeah, we've got 2 of these little dummies here. And service, yeah, we also turn it into a service object. And this is what we've got. So on the black part, this is how our topology of our code looks like with the just idea of types of work, and with this idea plus the idea of service objects, we get this amount of complexity. So we get, I would say we get a decent amount of accidental complexity here. And this is what I mean. This is what I mean by finding an optimal way to organize complexity. So on the left, this is what we had before refactoring, and this we don't like because complexity would grow inward, and we will get infinite number of private methods. And on the right, this is what I would get if I would keep using service object, even if I don't have to. So, and this is how it's going to look like on a scale. So this is how some of my shelves for building blocks for different types of work look like. So I have services, I have mutators, I have managers. Managers in my code are just wrappers around external services. I have forms, I have business rules. They go just as a method to my models. And yeah, I get this layered architecture. And at this point, I would like to rename my talk. And new name of my talk would be The Shape and the Missing Idea of a Service Object. Because at this point, I think there is no idea, there is no philosophy in service object. I think the only idea of a service object is its shape. And what I very much dislike about this is that it makes you focus on a wrong thing. It makes you focus on an empty concept. Instead of really organizing your code, you're just focus on the shape. And this is what we get. So we just get a very, very different service objects which either do different types of work and they are put into the same bucket, or worse, inside service objects they do all the different types of work and they still put in the same bucket, and this bucket is located it's located nowhere and everywhere, because it steals all the responsibilities from controllers layers and all the responsibilities from the model layer, and it does everything basically. So with this idea, we effectively kill layered architecture. And one more thing I want to share. Like, not only I did some research about how developers do service object, I also tried to find how smart people who were thinking about it like years before, in this example Fowler and Evans, what they were saying about service objects. And surprisingly, they didn't say a thing. So, but what they said about, Fowler mentioned an idea of service layer, and Evans mentioned domain services. And I'm not gonna share the whole story, but what I did basically, I represented visually what they were saying, and this you will be able to see in details in my presentation, which I am gonna share in the end of my talk. And Evans' ideas, they look like this. What I wanted to share here is that I took their ideas and I kind of decided to make it more compact. I assumed they were talking about the same idea because it looks like it, and I kind of compressed what they were saying about. And this is what they were saying about. So they're saying that the domain service is stateless. It is named for an activity, not entity. It represents business operation. So some calculation, some random calculation is not a business operation. A wrapper around a REST API is not a business operation. It coordinates domain objects. It controls transactions. It should theoretically have side effects. It could happen that there will be no side effect because some if condition. But theoretically, there should be a side effect. And there should be no application logic, because Evans specifically, he draws the line between domain services and technical services. And he says those are not the same, those are different things. So, and what we've got here is that we actually crafted a ruler here. And we can take every service around, we can grab any service object, and we can measure with this Fowler-Evans ruler and see, to what extent it matches what they were saying. And the good news is that I actually, I made a custom chat GPT where you can put your code and it will tell you how many points it gets according to this ruler. And if you get 5 out of 7, most probably you're using service object where you don't have to, where function will be enough. I recommend you to play with it. It is fun. And my general recommendations: don't use the term service object, because again, it's an empty concept, it's an empty abstraction, there is no deep philosophical idea behind it. Second recommendation, don't use service objects. You still can, but if you do, you should be ready to answer the question, what is your personal idea behind it? So you can still use it as a technical trick if you find it useful. I don't find it useful. I find it confusing. And types of work of your code is doing is essentially types of building block you have in your applications. And yeah, do try to measure your services with Fowler Evans ruler. And the good news is that all this stuff is pretty easy to find. Just go to rails.services. There I put my presentation. There I put some links from the talk. There I put the link for this Fowler Evans ruler. And there you can find the recording of my talk in Poland, 1 hour long, where I was talking about all this in much more details. Thank you. And one thing I do, if you disagree with me, please find me and talk to me. I would love for you to explain me why service objects is a good idea. Maybe I'm still missing something. I would love you to tell me that. Thank you.